Exactly. Great job. It does shift it up 4. So 1, 2, 3, 4, and this will be the graph. And you can say, but why did you find the points? I'm just making a point. Yes. As you see, 0, 4 is right here. 1, 5 is here. 8, 6 is somewhere here, and so on and so forth. I did not determine this intercept, the x-intercept. I have the y-intercept, 0, 4, but I like to determine the x-intercept. So how do we find the x-intercept for any function?
Include y to 0.
Set y equal to 0. Thank you, Lake. That's awesome. Yes. So then I have the cube root of x plus 4 equals 0. That's our function. That's our y. We're setting it equal to 0. What type of equation is this?
Polynomial?
Careful, careful. Polynomial has to have x and some integer positive number. Say it again.
Would it be quadratic?
Quadratic will be something with x squared plus x minus 5 equals 0.
Exponential? Radical?
Yeah.
It has a radical, right? We're talking about radicals in this problem. So it's a radical equation. Radical equation, like before, I have to move 4 to the other side. The cube root of x equals -4. What do we do next? Does anyone remember how to address this next step?
You raise both of them to the power of 3?
Why not to the power of 4?
Because
why do I choose 3?
It's the cube root.
Of course. So only power 3 will destroy or make the cube root disappear. And -4 to the third power is -64. So that's why I did not plug in -64 to get that. So the x-intercept is -64, 0. The y-intercept is 0, 4. Now, I'm going to share my screen. Oh, I have a chat there. Is that for me? I'm not.
Oh, that was me. I just ran to the bathroom, so I put.
Oh, that's okay.
Just in case you called on me or something.
Okay, that's okay. Thank you. Okay, I want to share the screen because I'm very proud of the fact that our school gave me a license for the TI emulator, so I don't have to try to torture you and show the calculator in the camera and you couldn't see or you can see. Okay, don't embarrass me here. Okay, so go to y equals. Clear if you have anything.
I have a question.
Please, yes.
Right now I don't have my graphing calculator, so I'm just like, do I need it?
You will need a graphing calculator.
Yeah, I just don't have it with me right
Oh, that's fine. That's fine. That's fine. I'm not going to ask you anything about this graph. I just want to show you show everyone how to graph it, okay? Okay, so there are several options. I prefer, that's my prerogative, my personal preference, x raised to. You don't know me yet, but you will very soon. I like to put parentheses everywhere. In certain newer calculators, the reason I show every step like that is because if you have an older calculator, you will need to put parentheses if you are using this. Yes, you can use the math and use the cube root of x directly. So go to math and just use option 4. So that's perfect. Okay, I prefer writing x raised to 1/3 because that's me. The cube root means power 1/3, not power 3. The cube root is power 1/3. The square root is power 1/2. The fifth root is power 1/5. Okay, and then plus 4. Since I know the x and y intercepts, when I go to the viewing window, I will make adjustments. If I stop at -10 or I start the leftmost point at -10, I'm not going to see the x-intercept. So I'm going to suggest -100. X maximum, moving forward, x maximum 10 is good enough. The scale, because it goes from leftmost to 100 to rightmost to 10, I would make it a 20. Y minimum, I prefer -10, that's fine. Y maximum, +10 is fine, or if you'd like, we can put it 20. I will change the scale at 5. And at this point, I'm ready to graph and click graph. Okay, so I do see the x-intercept. If you want to see more to the right, we can go back to the viewing window and change the x maximum to 50. And now we're going to see more to the right. So we know that this intercept is at -64, 0. We know that the y-intercept is at 0, 4. This is 5, so this is 0, 4, and the rest is history, as we say. Okay, so that's a much better graph, but after we found the x-intercept. Any questions? Okay, anything else about graphing? Do we need to choose anything else, or we move on? So these are the steps for graphing. You have to start with a domain. You have to plug in numbers. You have to check with the graphing calculator just in case. Maybe you need to find the x and y intercepts by hand so that you know how the graph looks like, so you can adjust the viewing window. Are we okay with these? Anyone? Okay. I couldn't hear you.
So can we do one more graphing, please?
One more graphing?
Yes.
Okay. So let's do the absolute value, x minus 3 minus 2. So y equals the absolute value of x minus 3 and minus 2. Good. We start with the domain. Can anyone give us the domain of this function?
X has to be greater than 0
Why?
because it's absolute value.
The absolute value exists from 0. The absolute value exists from a negative number. The absolute value exists from a positive number. Friendly. Always friendly. Unless it's in the denominator, always friendly. Is that okay? So domain indeed, -infinity to infinity. We are able to plug in anything we want in this function. Okay, so let's say -4, -3, -2, -1, 0, 1, 2, 3, 4. So let's quickly plug in -4 and give me the answer.
5.
Okay, -4 minus 3 is -7. -7 minus 2 is indeed 5. Awesome. With -3.
4.
Yes. With -2.
3.
Very good. With -1. Good. With 0.
-5?
0 minus 3 is -3. The absolute value of -3 is 3. 3 minus 2.
1.
Good.
Or negative, yep.
With 1.
Would it also be 2?
So 1 minus 3 is -2. The absolute value of -2 is 2, and 2 minus 2 is?
0.
Good. Let's plug in 2.
-1.
Yes.
Negative.
Yes. 2 minus 3 is -1. In absolute value is 1. 1 minus 2 is -1. Perfect. With 3?
-2.
Good. With 4?
-3.
Careful.
-6.
-1.
So 4 minus 3 is 1. 1 minus 2 is -1. Okay, let's try one more. Let's see, 5.
0.
Careful. So 5 minus 3.
Is 2. Minus 2 is 0.
Good. Okay, I think that's good enough. You want to try also 6? Let's try 6.
That would be 1.
Very good. Okay, we're ready now to plot all these. Here it is. From left to right, the first ordered pair, please.
-4, 5.
Very good. -4, 5. Next one.
-2, 3.
Good. Next one.
-2, 3.
Good. Next one. I'm going to jump to this. I'm going to jump to this. At 2, -1. At 3, -2. At 4, -1. At 5, 0. At 6 is 1. So here's the function. It also bears a name of the v function. The absolute value, same with v function. So if we want to, I'm going to share my screen again. If we want to graph this, we go to math. Oh, first y equals and clear. And then we go to math and we go to numbers. And this is the very first one, the ABS. So click enter. And we put x minus 3. And then outside -2. We already know the graph. So in this case, the zoom 6 will work. Standard zoom 6. Because we know the graph, it's not too far to the left, an intersection, or too far to the right, or I don't have to truncate anything. It's good enough. Can anyone give us the range of this function?
Why is infinity?
So let me stop sharing because I need to show here. So for the range of the function, we start from the lowest y value. It does not exist. It does not exist. Yes, it does. It does, it does, it does, it does, it does. So the range is?
-2 to 3.
Very good. What type of symbols we use?
Bracket and 2.
Great job. This is the lowest y value, -2, and the highest y value is infinity. Great job. Okay, now I'd like to move on to number 5, and I want to do number 5 together with you, because number 5 is slightly more, not difficult, but a different, a totally different situation. 2, if x is less than or equal to 0. 1 minus x squared, if x is between 0 and 2. And the square root of x plus 5 for x greater than or equal to 4. This is called, anyone remembers how this is called?
Piecewise.
Thank you very much. Who said that? Thank you, Rita. I meant S here. Piecewise defined function. This is S. Piecewise defined function. Yes, we have to find its domain first. Like before, we're asked to graph, so we have to go through the domain first. Okay, now my first step is to change this into an interval notation. Can anyone tell us the interval notation for this? Just for that. Negative infinity, comma, 0, correct? Okay,
Yeah.
can anyone give us the interval for this?
Zero, comma 2.
Excellent.
Both in parentheses.
Perfect, awesome. Can anyone give us the interval for this?
Would it be 4, infinity?
Great job. So this is the domain. Negative infinity to 0, awesome. 0 to 2, awesome. But now there is a gap between 2 and 4. So here's how we present the interval. Negative infinity to 2, 4 to infinity, and nothing here. There is a gap in this function. Okay, coming back. 0 must be in the table. And if you notice, there is a bracket to the left of 0, and there is a parenthesis facing right. These two symbols have to be identical, have to be right under 0, touching each other. The bracket and the parenthesis, they're touching and they're exactly under 0, not skewed left or right. 2 has a left parenthesis. Okay, fine. And 4 has a right bracket. Right exactly under 2, exactly under 4. Okay? At this point, we have to identify which function we use for each piece. Can anyone tell us which function we use for the first piece?
2.
Of course, that's it. That's what it says. It says if x is between negative infinity and 0, you have 2. Good. The second piece, the middle piece.
1 minus x squared.
Great job. And the final piece?
Square root of x plus 5.
Good. Okay, perfect. So now on the first piece, no matter what I plug in, I get 2. And 2 is written right inside the bracket. If I plug in negative 1, I get 2. If I plug in 0, I get 2. If I plug in negative 5, I get 2. This is all 2. I was allowed to plug in 0 here because of the equal symbol and the bracket. On this side, I am going to plug in 0. And you should say no. It's a parenthesis. It's not going to be a function. How can you plug in 0 in both? Here there is no equal symbol. Just bear with me and you'll see what happens. So if I plug in 0, what do I get?
0.
1. And I put it right inside a parenthesis. Now let's plug in 2. And you can say no. I will ask you to bear with me and just plug in 2.
-3.
Excellent. Okay, so now let's plug in 4 inside the bracket. I would write
9.
The square root.
I mean 3.
Very good. Awesome. And let's pick another like 11. And what do I get? Why did I pick 11? Because I need a number that I can take the square root from.
That would be 4.
4. Excellent. And now let's graph. Okay. The first ordered pair is -1, 2. The second ordered pair is 0, 0, 2. This is my second ordered pair, 0, 2. Full point. And I finished the left-hand side. I cannot continue this line to the right. This is done. I'm using this color. I'm going to use green next. Can anyone give us the next ordered pair?
0.
What type of point is it?
So, excess.
It's a circle.
Very good. Or also called an open point. It's an open point. The function cannot be at 0, cannot equal 2 and 1 at the same time. And we have also at 2, -3. What type of point is 2, -3?
Also open.
Also an open point. Yes, I should also plug in 1 in here. It's an important point. What do we get when we plug in 1?
0.
That's it.
0.
This in green is the second branch, and this is a parabola. It's not a straight line. It's a piece of this parabola. I can only graph this piece between 0 and 2. With a different color, I will move on to the last piece. So this was 2, 3, 4. 4, 3. Is it a full point or an open point?
Full.
Very good. And I need 4, 5, 6, 7, 8, 9, 10, 11, 4. It's not a straight line. It's a square root. So this is our piecewise defined function. You understand that you cannot extend this to the right, you cannot extend this to the left and right, and you cannot extend this to the left. And this is the piecewise defined function. Can anyone give us the range? It's not a friendly situation for the range. So it starts with an open point at -3. It continues, yes, 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 1 with an open point. Union, no, 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 yes, with braces, just 2 inside. And then no, 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 till 4 to 3 to infinity. So union again, with a bracket this time, 3 to infinity. So this is a piecewise defined function. You understand that if you extend and not keep each piece separate, you're not getting a function. Okay, so I want to review 6 and 7. Say it again.
I have a question.
Please.
Why did you put a brace around 2?
Because 2 cannot be an interval. You cannot write 2 as an interval.
Okay.
So, in other words, I'm saying that the function does not exist here. Yes, 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 yes. No. Yes, just one number. And then no, 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 and then 3 to infinity. So this is just one value. One value cannot be presented in an interval notation. Has to be, or any finite. If it's 2 and 3, it will be 2 comma 3 or 2 comma something. But in between does not exist. So I can only use braces. I have to use braces to represent one number. Any questions?